Greetings and welcome to using the TI-84 Plus. I'm your presenter Lynn Mann. In this lesson, we'll be going over the functions normal PDF, normal CDF, and shade norm. When working with the TI-84 Plus and the normal distribution, there's quite a few things that we can do. So let me start off by saying I am going to graph some of these problems. And to do that, we're working with the mean of 63 and the standard deviation of 5. And that's going to determine what settings I have on my window. So let me share with you what settings I have. Because we know by the empirical rule that 99.7% of our data falls between 3 standard deviations above and below our average, I've already set my window up to allow for those 3 standard deviations. So 3 standard deviations would be 15 below 63 and 15 above 63. And I just kind of expanded my window just a little bit more to include just the tail a little bit more. So instead of going from 80 or 48 to 78, I just added 2 on each side. The Y min and the Y max, I just kind of figured out by keying in some stuff. I started with, I don't know, I'll start with a Y min of 1 and a max of 1, and then I just kind of finagled it from there to see how it fits on my window the best. And I actually like the setting of negative 0.05 and the Y max of 0.1. I like the way that it sat on the screen, so I left it like that. You could certainly play around with these settings and see what you like better. Now let's say we have a question and we want to know, using the mean of 63 and the standard deviation of 5, what's the likelihood, what's the probability that our score will be more than 65? So let me get out of here in the Windows settings, and there's a couple of ways of doing this. First and foremost, I want to see what my normal distribution actually looks like. So I'm going to plot my normal curve. And I'm going to go to Y, second vars. Normal PDF is the curve itself. So I'm going to say 1. My X value is just X values. I don't know what my X value. I'm not plotting a specific point on my normal PDF. So I'm just going to hit my X key right here. I do know what my mu is 63. My standard deviation is 5, my sigma. And I'm going to go ahead and graph this curve just to see what it looks like. And it looks like a normal curve. Beautiful. Okay, so now that I know what my curve looks like, I want to know what more than 65 looks like. There's a couple of ways of doing this. One is I can graph it. I can actually graph it and it will give me the answer, or I can do it mathematically. I'm going to do it both ways so you can see how to do that. To do it graphically, I'm going to go to second, distribution. Instead of staying in with distribution, I'm going to go to draw. I'm going to tell it to shade my normal curve. I need a lower boundary and upper boundary. What is my average and what is my standard deviation? I do need to plug in these values. My lower boundary, since I want more than 65, 65 is going to be my lower boundary. My upper boundary, remember the normal curve really goes off to infinity, so I need a large number. I'm going to use 10 to the 99th, and I'm going to put it in as scientific notation. I think it's just faster. So second comma, that gets it in scientific notation as the EE. And I'm just going to say 99. To the calculator, that means 10 to the 99th. To us, it just looks like E99. All right. Now I need average. My mu is 63. My standard deviation, sigma, is 5. And I'm going to color it blue. Why not? And I'm going to go ahead and draw it. Now, because I already have the curve of the normal curve already drawn, it's not going to look like it's doing anything for a little bit, but just hang in there. It will draw it. It's actually tracing over the normal curve that's there, and then it's coloring in more than 65. And the cool part about this is not only do we see the curve and the shaded region, we also see the area, which is the probability. So our probability that our value is more than 65 is 0.3446. Now, if I didn't want to do that graphically and I wanted to do it just mathematically, I could go to second distribution and go to my normal CDF. My lower boundary is 65. My upper boundary is that very big number, so I'm just going to do second EE99. And my mean is 63. My sigma is 5. And this will just calculate it. It won't graph it, it will calculate it. So 0.3446, which is exactly what our shaded region gave us, except it gave us a pretty picture as well. So if you want to see it as well as get your answer, you're going to go to shade norm. If you just want to get your answer, you can go to normal CDF. I think shade norm is kind of cool to do if you already have your Windows settings. If you don't, then normal CDF is going to get you the answer a lot faster. Now I want to know, what's the probability that my score will be less than 85? And I'm going to do it both ways. I'm going to shade, I'm going to norm, do the normal CDF. But I need to clear out the shade that I have already. So I'm going to go to second draw, which is right here, and clear my drawing. Okay, so my draw is now, if I went to graph, it would just graph the normal. But I am going to go to second distribution, draw, shade norm, and this time I want to know less than 85. So my lower boundary is this very negative number. So I can just hit enter. My upper value is going to be 85. My mean is still 63. Standard deviation is 5, and I want to color it in blue. That's fine. And I want to draw it. Now I didn't draw the normal curve first, so you can see that the shade draw does draw the curve as well. And now it's shading it. Wow. So it shaded everything. In fact, my area is 1, so the probability is 1.00. Now, why is that? Well, when you think about it, remember, 99.7% of your data is going to fall between 3 standard deviations above and below. 85 is more than 3 standard deviations above our data. 78 would be that 3 value, the 3 standard deviations away, and this is well above it. It's going to say that the whole entire area is shaded. So the probability that our value is going to be less than 85 is 100% or 1.00. If I just want to go through and I want to solve that problem without going through graphing, I'm going to go to normal distribution. My lower boundary is going to be an extremely low value, so second, let me go back and say distribution, and I want 2. My lower boundary this time is going to be extremely negative small number. My upper boundary is going to be 85. My mean and my standard deviation remain the same. And we still get the same answer of 1.0000. So both ways will give us the answer. What if I want to know the probability between 60 and 73? Again, I'm going to draw this and then I'm going to just solve it mathematically. First, let me clear out my draw. And now I'm going to go to my distribution, go over to draw, and shade my norm. My lower boundary this time is 60. My upper boundary is 73. My mean was 63. And standard deviation is 5. Again, it's going to draw the curve, and then it's going to draw in the shaded region for us, and it's going to tell us the probability as well. So all three of those things happen. It's really kind of cool. And our area is 0.7030. Now let me go through the mathematical. Second vars for distribution, normal CDF. Sometimes why it doesn't give me my menu, I don't know. Okay, there we go. Lower is 60. Upper is not 85, upper is 73. And mean and standard deviation are the same, 63 and 5 respectively. And we get the same probability, 0.7030. Now that's working with normal CDF. That gives us the mathematical answer. Normal PDF will help us draw the normal curve. Shade norm will shade our normal curve, draw our normal curve, and give us the answer to our probability. Now, what if I already have the probability? We want to find the score for the 90th percentile. That means I have the probability. 90% of the scores are going to be below our value. That's the 90th percentile. This time around, I need to go to INV norm, inverse normal. So we have our probability, we need to find our X score. So I'm going to go to inverse normal. Our area under the curve is 90th percentile, which is 0.90. Our average is 63. Our standard deviation is 5. And therefore the score, the X value that we actually need, is 69.4078. Now let's say you're in a class and your teacher goes by, hey, in percentiles, this is the score you need to keep your A grade in class. And he says to you, you need to be in the 82nd percentile. That means 82% of the scores need to be lower than yours for you to keep your A in the class. And so you want to know, what do you have to score on that test? Second, vars, inverse, and you wanted to be the 82nd percentile, so 0.82. The rest is the same, 63 for your average, 5 for your standard deviation. So you must score 67.5768 to be in the 82nd percentile in your class and keep your A grade. So that's it for this lesson on normal distribution and the TI-84 Plus. Until next time, be seeing you.